Okay, this is Unit 2, Lesson 5. This is about line segment bisectors. So we're going to talk here about things that we already know are bisecting a segment, and we're going to use those in order to find out certain information about a segment. So here's where we start. First thing is that a line segment bisector can be any one of these things. It can be a point, like this in the diagram, or it can be a line or line segment, and that looks like this. Okay, notice in each case here that we have point M on the line segment, and that is our midpoint. Okay, and then we also have that it can be a plane that bisects a line segment. Okay, in that case it would look like this. Notice in each one of these cases that the length of AM is equal to the length of MB. Okay, and that's one of the things that tells you that whatever figure is cutting through a line segment, that is what it is. Okay, that it is a bisector on that basis. All right, then let's look at example 1. Line segment GH is bisected at point M. If the length of GM is equal to 3P plus 2 and the length of MH is equal to 15 minus 3P, they want you to find the value of P. Okay, so here's what we have. We draw the situation out with a diagram. So we have a line segment GH, and a midpoint on that segment is M. Okay, so we know that the length of GM is 3P plus 2, and the length of MH is 15 minus 3P. Since we know that M is the midpoint, we know that these two things have to be equal, and that's how we go about solving for P. So this gives us GM is equal to MH, which I just said, okay, and that's because M is the bisector. So 3P plus 2 equals 15 minus 3P. Subtract, or actually add 3P to both sides and subtract the 2 from both sides. That gives us 3P plus 3P is equal to 15 minus 2, which results in 6P equals 13. So P is equal to 13 over 6. So that is the value of P. That is not how long this is. If I want to know how long it is, I have to actually put that back in here and calculate it out. But the only thing they asked us in this question was, what is P? So that's where we're going to stop with this problem. All right, let's move on to example 2. Okay, this says P, Q, and R are collinear, with Q being somewhere between P and R, but not necessarily halfway in between. Then they tell us that if the whole length of the line segment PR is equal to 20, and the length from P to Q is J plus 8, and the length from Q to R is 2J plus 6, they want to know if Q is the bisector. Okay, so if Q is the bisector, these two things would have to be equal. So what we have to do here is solve this for J, and once we find J, plug it back into both of these and find out whether those are the same values. Okay, so the first thing we're going to do is we're going to draw the diagram. So we draw a line segment PR, and we put a point Q somewhere between them. And it said not necessarily halfway between, so we can't assume this is halfway. So here's what we do. We know that 20 is equal to this length plus this length. So that's how we're going to solve for J. Okay, so the first thing we're going to do is PQ plus QR equals 20, which is just saying that these two things equal 20. So we put in the algebraic expressions for those. We have J plus 8 plus 2J plus 6 equals 20. Combine like terms gives us 3J plus 14 equals 20. Now we're going to move the 14 to the other side by subtracting. So 3J is equal to 20 minus 14, which gives us 3J is equal to 6. So when we divide 6 by 3, that gives us that we have 2 for the value of J. Okay, so now we substitute back into these to find out if this and this are the same length. So we substitute in 2 for here, so this 2 plus 8 equals 10. So PQ is 10. Just plug in for QR. This gives us 2 times 2 plus 6, and that comes up to 10. So since both of these come up to 10, then we know that Q is actually at the midpoint of the line segment. Okay, so Q is the bisector of segment PR. Okay, let's look at example 3. Okay, example 3 says you have line AB and that it bisects segment RT at point A. If the length of AT is equal to 3Z plus 6 and RA is equal to 11Z minus 18, they want you to find the value of Z. Okay? So here's what we do. Go ahead and draw our figure out. So this is what we actually have here. We have AB. This is the line that's bisecting the line segment RT. And the intersection of the two is at point A. So what they're telling us is that this piece right here is 3Z plus 6, and this part is 11Z minus 18. So what they're telling us is since it bisects, we know these two things are equal. So AT, so that gives us 3Z plus 6 is equal to 11Z minus 18. What they're doing here is they're moving the 11Z over here, and they're moving the 6 over here. Both of those are by subtraction. So this gives us 3Z minus 11Z equals negative 18 minus 6. Combine like terms on each side gives us negative 8Z is equal to negative 24. Divide both sides by the negative 8 gives us that Z equals 3. Okay, since the only thing they're interested in here is what the value of Z is, then that gives us the answer. If we wanted to know how long AT was, we could plug the 3 back here, and that would give us the answer to that as well. Okay? So one thing that this gives us now, we've now got a little bit of experience with geometry. One of the things we're going to do next week is this, it is appropriate to discuss different types of geometry. So next week we're going to have an activity where we're going to talk about a thing called taxicab geometry. Okay? What we're studying in here primarily is Euclidean geometry, which is also called plane geometry. So if you see those two terms, those are interchangeable. Okay, make sure if you have any questions about this to get them onto Post-its tomorrow, and we will use those to answer before we actually start the work. Thank you very much. See you next time. Goodbye.